Welcome back to the Diet Doctor podcast. I'm your host, Dr. Brett Scher. And today's episode brings us to the end of another year of the Diet Doctor podcast. So I want to start by saying thank you. Thank you for listening. Thank you for tuning in. And most importantly, I hope that you have found these episodes over this past year to be helpful, to help you see health and nutrition and fitness in a different light, to help see the science of health in a different light, and to take all these lessons from our experts and our deep dives into different topics to come away with practical tips as well as better understanding to help you on your health journey. We're all on different health journeys. And while podcasts like this can't give you specific advice, they can provide general information and tips that may work in general for many people. And I hope you've been able to come away from these podcasts with that knowledge and that empowerment to improve your own health in some way. And I'm honored, really, to say that we've had 2.2 million views and listens to this podcast in 2021, which is great. I mean, it's just phenomenal. And I really am honored to be able to say that. So again, thank you. So what are we doing for our end of the year episode? Well, we're going to review my 10 favorites, my top 10 favorites from the year. And it's tough picking 10 because there were a lot of really good episodes that I enjoyed. I enjoyed every single one of these conversations. But these are my top 10, and not in any particular order. But what I'm going to start with is protein, because we had three really good episodes on protein to talk about the importance of protein, what it means to get enough protein, why we need enough protein, plant versus animal proteins, the practical tips we need to know. So let's jump right into it with episode number 70 with Dr. Ted Naiman. Now, Ted's awesome. He's just a great guy. He has a great perspective on things. He takes great care of himself and is really committed to taking great care of his patients. In this clip, we talk about the differences between plant and animal proteins and how they're not the same. And that's so important right now. It's really timely right now because of this push for plant-based meat substitutes, which, for some people, if they really don't want to eat meat, could be reasonable approaches to get more protein. But for people who want to eat meat, I don't see the need to go to these others, and there's a reason why they are inferior. Inferior from the sense that the protein quality isn't as high as animal meat. Doesn't mean you can't get your protein needs from them. You can. It just comes with more carbs and more calories. For some people, that makes a difference. For some people, it doesn't. But it's important to have that nuance, that level of discussion. So in this clip, that's what we talk about. That's what I talk about with Ted. But in the episode itself, we go through so many other aspects of protein. So I really highly recommend this episode. And let's hear this clip with Dr. Ted Naiman. Now, the other concept of not all protein being the same is plant versus animal protein. So some of those same observational studies seem to suggest plant protein is better than animal protein for health and longevity, although, we've talked a lot about observational studies, nutritional epidemiology, healthy user bias that make that very difficult to interpret. But how do you see the main differences for plant versus animal protein? Because like you said, broccoli and spinach have a huge percentage of protein per calorie, but is it different than eating a steak for your protein?
Right. Yeah. I think that unfortunately plant protein is inferior to animal protein for two main reasons. First of all, it's frequently not a complete protein. So plant protein is great for building plants. Animal protein is great for building animals. Mm-hmm. If you want to build an animal out of plants, you have to mix and match a little bit. It's like a Lego kit, and if you have one Lego kit here and another Lego kit here, you can't build the second one from the parts of the first one. If you combine different plant proteins, you can make a complete protein with all the essential amino acids. But it's definitely not as good as animal protein in terms of completeness for animals. The other problem is digestibility scores. And unfortunately, all of that fiber in plants, which is great for satiety per calorie, is actually kind of bad for extracting protein and minerals. So the proteins are less bioavailable. And pretty much anyone who seriously researches protein will tell you that animal proteins are always superior. And even in the animal protein world, there are some proteins that are just considered the gold standard, like whey protein and egg whites are extremely digestible, bioavailable, and complete. And so those are usually sort of your gold standard proteins that everything else gets compared to.
Now, to continue on the protein theme, we had a compilation podcast with the man himself, Diet Doctor, Dr. Andreas Eenfeldt, along with Adele Height and Franziska Spritzler, the two registered dietitians and senior authors at Diet Doctor. In this compilation podcast, we really went into a lot of the specifics about protein, the challenges of eating too much protein, again, why it's important, and the tips on how to get it. So another great episode to really understand not just the science of getting more protein, but the practical nature of how to do it and what a lot of the pitfalls are. And Franziska and Adele are amazing in terms of their experience of helping people eat more protein. So they have a lot of good pearls. But in this clip, we're going to talk to Andreas and talk about the importance of healthy weight loss and how hunger is such an important aspect of healthy weight loss. Because let's be honest, if you are hungry on a regular basis on your diet, chances are you are not going to succeed with that diet. And protein is a very important component to addressing that hunger and improving your chances for healthy weight loss. So let's see this clip with Dr. Andreas Eenfeldt. When it comes to this concept of healthy weight loss, what are the factors that you think are most important? And as a follow-up then, and how does protein fit into achieving those concepts of healthy weight loss?
One fundamental thing is that in order to achieve weight loss in a sustainable, enjoyable way, you have to feel satiety. You can't be hungry all the time. Nobody wants to be hungry all the time, and nobody, I think, almost nobody is able to do that. I know I wouldn't be able to do that. So in order to achieve weight loss, you really have to focus on eating foods that bring you a lot of satiety with not a lot of empty calories, not a lot of, basically a high satiety value per calorie, if you will. Tying that back to protein, that tends to be high protein foods in general. That is, protein is the most satiating macronutrient, more so than carbohydrates, more so than fat. And it also comes with all these other nutrients, usually. So then you can eat less food and still feel full, still feel happy about it. Another bonus is, which is also important, I think, for sustainable healthy weight loss, is you want to lose fat mass, perhaps excess fat mass, but you want to maintain the lean mass, the muscle mass, the bone mass. You need all these nutrients to, your internal organs and everything. And that's what you get also with the high protein foods and the high nutrition foods. I think it fits together quite well. Other aspects of healthy weight loss, of course, is, you want to be metabolically healthy. You want to have a good health markers, blood pressure, blood sugar, cholesterol profile, etc., etc. And if you go on a higher protein diet that is doesn't have excessive amounts of carbohydrates or added fats, then that tends to be helpful for that as well.
And then the last one to bring up in this set of three, focusing on protein, is episode number 776 with professors Raubenheimer and Simpson. And boy, these guys, I have a lot of respect for these guys. And I really enjoyed this episode, as I enjoyed their book, because they talk about the protein leverage hypothesis. And this journey kind of blows my mind. That's why I love their book. It reads almost like a fiction book in a way. It's got adventure, it's got their explorations and their experiments out in the field, and then how that translates to human experiments. But here's the thing that I think is just so great is these two professors, scientists, they call themselves bug doctors. They're scientists who focus on bugs, yet through their scientific journey, they've uncovered what could potentially, at least in part, explain a great deal of the human obesity epidemic. And I talked to them in the interview about how there was initially some pushback, like, oh, you guys are bug doctors. We're not going to listen to you. You don't know what's going on with humans. But it turns out their protein leverage hypothesis that started in bugs absolutely does seem to apply to humans. And I love that journey that they went through. And This shows the importance of scientific exploration. This shows the importance of scientific curiosity and of designing experiments and being committed to your experiments. And look, I'm not going to say I agree with everything they say. We don't see eye to eye on maybe some of the dangers of too much protein or animal versus plant proteins. We may disagree somewhat, but I still 100% respect their scientific integrity, their scientific journey. And I really enjoyed this episode. So here's a clip where we talk about the protein leverage hypothesis. Here's a little snippet of that, but I highly recommend watching the whole episode. Why you think protein rises to the top? Why is it that people will, or I guess the animals and presumably people as well, will prioritize protein over those other appetites?
One really important answer to that is that we don't have a protein storage capacity like we do a fat storage capacity. And that means two things. It means, firstly, that on a daily basis, we need to ensure that we satisfy our protein requirements. So we need to ensure that we get enough. The other thing that it means is that if we overeat protein, there's no opportunity to store it for the future. Now, fat and carbohydrates are very different in both of those respects, and that gives human biology less latitude over our protein intake than what it does over fat and carbohydrate intake.
The other critical thing, obviously, about protein is not only is it an energy-yielding nutrient, like fat and carbohydrate, the other two macronutrients, but it also contains nitrogen, and you need nitrogen to build just about everything. You need reproduction requires nitrogen. So too does growth. So too does all the essential functions of cells and cellular maintenance require nitrogen in the form of proteins that ultimately come from the diet. Where unlike some other organisms in the world that can take atmospheric nitrogen and fix it and then use it to build their own nitrogenous tissues, we can't do that. We rely on it to come from our diet. So protein is the source, the principal source of nitrogen in our diet. Hence, it has this double importance, and coupled to the fact that we don't store it in any large separate storage organ, that means that it really becomes of great priority to us.
Now let's transition away from protein into exercise. Now, I'm a big proponent of exercise, but I'll be the first to admit that nutrition is probably first and foremost, not probably, nutrition is first and foremost when it comes to weight loss. But exercise plays a really important part of making sure that weight loss is healthy weight loss, because exercise helps us maintain our lean body mass, maintain our resting metabolic rate, and cardiorespiratory fitness can be so important. So we have two great episodes dealing with exercise. The first is episode number 75 with Professor Stuart Phillips. And we talk about the importance of muscle. He is a muscle expert. And he started working with athletes, and now he's working with sort of your everyday person and as people as we age to make sure that we maintain our muscle mass, we maintain our strength, and how that relates to our health. So this whole episode is packed with so much information. And what I love about Professor Phillips is that he really knows the science inside and out, and he knows the practical aspects of working with people and how to get people to integrate this into their lives. And developing muscle doesn't mean going to the gym and pumping iron and being, a huge weightlifter. And that's part of his clinical pearls and his knowledge of really the logistical and the practical aspects of making it work for each individual where they're at in their exercise journey. So here's a clip with Stuart Phillips talking about resistance training and the importance of muscle. In the 80s and 90s, cardio was king. Everybody was talking about the importance of cardio. And it seems like now maybe since 2010 or so, that now strength is king. And it's almost like you have to be in one of the camps. Either you're in the strength camp or the cardio camp. Cardio is for suckers, strength is great, or vice versa. Or is there an interplay between them? So someone who wants to maximize their health, their metabolic health, their fitness, their independence, what do you recommend in terms of strength, cardio, combination of the two? How do you see that?
You've hit the nail on the head. I think it's, I think when we get our textbook learning, and this is how we teach exercise physiology to our undergraduate students, is we have the bodybuilders here and we have the marathon runners here. And it's sort of like, this is the epitome of aerobic training. This is the epitome of resistance training. And I think the point I like to say is that these people are, in terms of their body shape, physique, size, and how fast and far they can run, they are 4 standard deviations away from the mean. I said, and the rest of you mere mortals, I said, we're all clustered in here. I said, so you can push yourself in one direction or another, but as you get older, it really benefits you to be aerobically fit for sure. So, and if it's only walking, I'm okay with that. But it does benefit you to be strong as well. So really, and I have a good friend and colleague at McMaster, Dr. Martin Gabala, and we have an online course where we sort of say, Dr. Gabala is the aerobic hit guy and I'm the resistance training guy. And then eventually we come back together and we're like, you got to have both. And, people who are going to do well into their later years are people who are cardiovascular wise are fit and strength wise are relatively strong.
Now, to continue on our exercise journey, we have a combination episode in episode 85 with Professor Martin Gabala and Phil Maffetone. And this was great because, I love the juxtaposition of the two, with Martin Gabala being the expert, the foremost expert on the science of high-intensity interval training, and how he talks about these exercise snacks or getting short bursts of exercise in and the importance of that. And he's clear to say interval training is a tool. It should be used as any tool would be used. It's not that it's the best type of exercise or the only type of exercise, but it is an important type of exercise that can be used as a tool in someone's overall health journey. So I encourage you to go back and listen to this episode for that wisdom from Professor Gabala. But also got to discuss this with Phil Maffetone, who is, I guess you could say he's really kind of the godfather of cardio training, at least in the modern era, and the importance of aerobic cardio training, which has kind of gotten a bad rap lately, right? It's all been about interval training and resistance training, but cardio and aerobic training still plays an important role. And it's good to hear Phil Maffetone's approach to that, again, knowing both the science and the practical applications. But then we went even further because he also is really an expert on seeing the combination of exercise and nutrition and the dangers when they don't match up. We've seen so many examples of people who exercise like crazy and are outstanding athletes, but yet developed metabolic syndrome or even type 2 diabetes. And we think, how could that be? Well, Phil has a great article and a great perspective on this, talking about the importance of exercise and nutrition together and how poor nutrition can absolutely override good exercise. And the combination of maybe too much exercise and poor nutrition leads to overtraining. So here's a clip where we talk about that, which is a small segment of what we talk about, which the overarching message was just the importance of aerobic training for health from his standpoint. And then, of course, with Martin Gabala, the importance of interval training. So let's hear this clip. A lot of times there is this like aura of health around them. You're an athlete, you're training, you're putting the time in, you must be healthy. So either I don't need to go to the doctor, or the doctor says, oh, you're fine. You're running, 5 miles a day. You're great. And the evaluation doesn't go much further. So I think that's one problem, that we just have to get over that sort of automatic halo of exercise equals health. But the other thing, this concept that we need to fuel our bodies. We constantly need to fuel our bodies. It starts with the kids, playing 20 minutes of soccer, and then they need their snack and their Gatorade or whatever for their 20-minute soccer game.
Yep.
But it also translates to grown-ups. You go for your 45 minutes on the treadmill, then you need to replenish with a sports drink and a carbohydrate. Like, how do you get that message to people that, no, actually you will be fine without that, especially if you train your body over time to burn fat for fuel? So what's that message?
Yeah, that's a tough message to get across to people, because the other message they're getting, which is you need to drink this junk, is coming from companies that are spending billions of dollars to tell people that, and they do it much better than we can. We're just giving them the facts. They're giving them the sizzle, and the sizzle is much more important than the facts. And when you have when you're showing the Olympics and the marathon is being run, and then it goes to a commercial and you get people guzzling down, that image stays with you. And that has been what's been ongoing since the 50s. And, we need the more carbs you can get in, the better, and all, because you need glycogen stores. And it's such a farce. It's just such a farce. And
Yeah.
I don't know. This is a public health problem, and public health really doesn't want to address it. Governments don't really want to address it. They're ignoring it. They're being lobbied by the same companies that are telling people to guzzle down the junk food drinks and eat the garbage. The so-called energy bars, which zap your energy, actually.
Now, moving from exercise, we're going to go to one of my favorite topics, cholesterol. As a cardiologist and lipidologist, I like to say cardiologist is near and dear to my heart, but I know a lot of people are probably getting sick of that pun because it's pretty bad. We had 2 really good episodes of doing deeper dives into cholesterol. And the first was episode number 86. And this was pretty exciting for me because this was a compilation podcast with Nick Norwitz, with Adrian Sotomoda, and with Dr. Tro Kalayjian, and of course, Dave Feldman. And the 4 of them, plus Dr. David Ludwig, who is not on this episode, came out with a paper, which is really sort of the first scientific definition of lean mass hyperresponder. And I find this so important because Dave Feldman started talking about lean mass hyperresponders back in 2017 when I had him on the Low-carb Cardiologist podcast. And through that 4-year journey, he's been able to really kind of revolutionize this small subset of lipidology. And it's sort of a brand new scientific exploration of what happens to this subset of people. And this paper is so important because it does define who these people are. Now, there's a lot of work to be done. It doesn't say whether it's safe or not safe, or it doesn't prove the etiology, but just by defining it and showing its correlation with lean body mass and with HDL and triglycerides and metabolic health, showing that correlation is such an important starting point. And I'm so proud of Dave and his whole crew, his whole team, of what they've accomplished. And so here's a clip with Nick Norwitz discussing some of the important aspects of this paper. What did you use as your criteria to define the lean mass hyperresponder?
We use the historic criteria that were proposed 4 years ago by Dave in a blog post, in which he would just kind of put it out there. And I think it's fair to use that was the origin of the term. And we were basically, what we did first is engage in a hypothesis naive exploratory analysis to observe the trends that are consistent with this model, and then go for these cut points of, as defined by Dave in 2017, LDL above 200 milligrams per deciliter, HDL above 80 milligrams per deciliter, and triglycerides below 70 milligrams per deciliter. That is what has come to be known as lean mass hyperresponders. And I think an important point to note is, one of the reasons I believe that Dave chose these 3 cut points is because each in and of themselves is a really strict cut point to meet. You don't meet many people with LDLs above 200 or HDLs above 80 or triglycerides below 70. So if independently they're rare, together they should be very rare unless they associate in a particular triad. Hence the lean mass hyperresponder. And another really important thing to emphasize, and this was kind of one of the findings of the paper, is it's confusing. The lean mass hyperresponder, that term, actually has nothing to do definitionally with BMI. And I want to pause there to emphasize that lean mass hyperresponder is not defined by leanness. It's defined only by this triad of LDL above 200, HDL above 80, triglycerides below 70. And the term lean came from the fact that just empirically, Dave was observing these people are kind of lean and athletic. And what this paper shows in part is not only does this group of people actually exist and they could be studied, but yes, they're actually leaner. So I don't like. One thing you could say is the lean mass hyperresponder term is a prediction about the metabolic phenotype, and that is validated by this paper.
And then, of course, the other episode discussing cholesterol was episode number 79, which was with Dave Feldman, again, a one-on-one interview, this time with Dave, where we really did a much deeper dive on his energy model and talking about his study, which is now live and enrolling, to enroll people who fit this lean mass hyperresponder criteria and follow them over time to see if they are developing any evidence of plaque. And for a guy who's an engineer and a citizen scientist and not a physician to be spearheading this type of new exploration in the field of lipidology, I think is so important. And he's teamed up with wonderful clinicians and scientists to really help make this a useful study moving forward. Now, is not without pushback, right? This is not going to answer every question about elevated LDL with low-carb hyperresponders. How could it? But it's starting the process. It's starting the process of saying this is scientifically worth exploring, and this is the first step. And depending on what we show, it may open the door for future experiments. And I have so much respect for him for starting the process. And I understand the pushback at the same point that it's not going to answer every question, but that's okay. You can't expect to on the very first study. But what this shows to me is the importance of scientific curiosity, the importance of scientific exploration, and how we can eventually draw the circle back to helping the individual, impacting the individual, and furthering clinical science. So here's a clip from that interview with Dave Feldman. For physicians who are unfamiliar with your work, or for physicians who are unfamiliar with low carb, the only LDL above 190 that they know of is familial hypercholesterolemia. So they will assume that any LDL above 190 is FH and needs to be treated. And that's exactly what the guidelines say. It's not just individual physicians, but that's what the guidelines of the American College of Cardiology, the American Heart Association. So have you gotten that kind of pushback? And if so, what is the little, in the back of your brain, do you have that little voice that says, what if I'm wrong? Like, what if this is not right?
Well, first of all, that voice is always there. And it should be emphasized that I definitely could be wrong. Even though I have a phrase that I like to use often, which is just 2 words, I like to say I'm cautiously optimistic. In the context of high LDL, as seems to be coming from being fat adapted, that's also an acknowledgement of uncertainty. I don't know for sure. And I've appreciated where everybody has been able to maintain a position comparable to mine, where they say, you know what, I have a good feeling about it, but at the same time, we really need clinical data to take us to the next step. A lot of the anecdotal data, I will say, I've appreciated. A lot of it looks good. I can't say that it's 100%, but that's because we're in a situation, which is often the case in so many of these circumstances, where you're looking for certain patterns and you're trying to make yourself look for the other patterns that oppose your view. But in spite of all of that, you cannot help that there's some amount of selection bias. And this happens with everybody. Everybody has their own confirmation bias that they're trying to fight against. I try to engage, yes, with the NLA, National Lipid Association, and other cardiologists as often as possible. And I can say that I've managed to make some really good friends with people who feel I'm definitely wrong. Conversely, there are quite a lot who are not as interested in having this discussion. But this is an important discussion to have, Brett. This is really kind of a crucial time, because while I know there are a lot of people who have, long before I came around, been skeptical, and probably would be whether I was around or not, there are a number of people who are thriving uniquely on a ketogenic diet, specifically on being very low carb, that have existing conditions for which it ends up being especially important for them. Epileptics, certain type 1 diabetics, certain people with severe digestive tract issues. I know a lot of these people because a lot of them reach out to me, and a lot of these same people are not comfortable with their high LDL. They're stressed out about it. Their doctor's stressed out about it. Their family's stressed out about it. And they have gone through multiple means of taking steps to lower it. But at the same time, they're struggling with their own doubts. They're saying, is this really going to be that important? And that's why we need clinical data, again, more than we've ever had before, because it's those people who we should get an answer for.
So next, episode 78 was another compilation podcast on seed oils. Now, boy, seed oils can be really controversial, especially within the low-carb space. And this is one of those areas where I struggle, because how I interpret the science is a little bit different than how I live my life and what I recommend. It's clear seed oils are, new, quote unquote, new in terms of the evolutionary framework of nutrition, right? They're brand new introduction in the scheme of things. How they extract the oil from the seeds is a kind of disturbing process. And there's mechanistic data that's really concerning about what seed oils can do to our health. But yet the vast majority of the clinical data does not suggest any clinical harm or poor clinical outcomes from those who eat more seed oils. So there's a bit of a contradiction between the different levels of evidence. So how do we interpret that? for either for a clinician, for the patient in front of us, or for just general individuals? How do you know how to interpret that? Because you have some people saying seed oils are healthy and should be encouraged. You have other people saying that they are incredibly dangerous and should be avoided at all costs. And I like to take a step back further and say, look, the whole purpose of seed oils or introducing seed oils was as a replacement for saturated fats, really. And I kind of think that whole concept that we need to replace saturated fats is very misguided in general. So it makes us wonder why we even need seed oils. But I think we have to be honest and very clear about what the science says. And the science is not so clear about how dangerous they are. It's also not so clear about how helpful they are either. So maybe it's a little somewhere in the middle. So in this one, we have a great compilation. We have a clip here from Dr. Ben Bikman, who's one of my favorites. I really love his perspective. But we also get perspectives from Dr. Tro Kalayjian, Dr. Ethan Weiss, from Nicola Guess, from Rafi Sortelli, and from Amber O'Hearn. So a really eclectic and different group with different perspectives on seed oil. So I really encourage you to listen and watch the whole episode to get those interesting perspectives and maybe see seed oils in a different light. When you look at a topic like seed oils, where there is a pretty big difference between mechanistic studies and randomized controlled trials and observational trials, some showing some significant concern, like mechanistic studies that they can be oxidized and pro-inflammatory and can have dangerous effects to humans. But when you look at observational trials, a number of them show actually a slight health benefit to those who eat more vegetable oils. And randomized controlled trials sort of show like a combination of both. Some show worsening, some show better health. So as a scientist, when you go into a minefield like this, how do you just sift through the science and try and prioritize to get to the truth or get to better evidence?
Yeah, so I think there are, you've said it well, actually, very well. So we have at the weakest end of it all, we have the purely observational studies, which is just here's a questionnaire and then tell us what you've been eating. And then we have one step better, which is a clinical study. Well, in fact, that would be maybe the best. And somewhere in the middle would be the mechanistic studies, because who cares if you identify a mechanism and it in no way reveals a pathology in the clinical study, no actual negative effect. So maybe I'd put it in that order. The observational is the worst, the clinical study is the best, and the mechanism explains what we see in the clinical study. Or it doesn't, and it wasn't that relevant. It was only relevant at the level of a cell, which is too artificial of a model. So yeah, on the observational end, and this is no surprise and nothing new to your audience, I know, there are so many potential biases that get their way worked in, that get worked into those kinds of studies, like healthy user bias, where a person that is tending to eat less processed foods, which is typically the common source of refined. Oh wait, I'm actually working against that argument. Well, people who are avoiding saturated fat, they are in favor of, say, seed oils because they've been told it's healthy. They're engaging in other healthy habits that just don't get accounted for in the questionnaire that they've been given. So I give very little weight to the observational studies. In fact, I think that's one of the plagues of modern nutritional science. I don't think epidemiology should be used in nutrition. I think it should only be used in true diseases, not just nutrition or not nutrition. Now, there are some big clinical studies, again, no surprise to your audience, the Minnesota coronary experiment, the Sydney heart study, which was almost as good as you could get in controlling an environment over many, many years, a long enough period of time to actually measure death. You and I both know most clinical studies are a few weeks, maybe a few months at the most. You just can't measure death in a few months. Mm-hmm. But these studies were very big. And of course, the bigger it gets and the longer it gets, the more potential error you introduce. But they totally refuted the idea that these polyunsaturated fats were better and over eating saturated fat. And in fact, suggested that the focus on polyunsaturated fat at the expense of saturated might in fact have been harmful. So that's what those two studies showed, that it was actually perhaps a net negative to cutting back saturated and focusing more on polyunsaturated.
Next up is episode 80 with Dr. Sachin Panda. Now, interviewing him about time-restricted eating and circadian rhythms was a real treat because he sort of is the godfather of of time-restricted eating research and circadian rhythm research. He's one of the originals and one of the foremost authorities on the subject. And he has such a good handle on the sciences. He's done so many of the experiments, but also is very good about helping to translate it into sort of practical, simple advice that people can just adopt, because he knows that the purpose of the research is to help people live healthier lives. And so in this clip, we discuss a lot of what that implication is, but in the episode itself, it's really about understanding the science, and how does that apply to individuals. And time-restricted eating is such a hot topic. I think you will enjoy this interview with Sachin Panda. What are your thoughts about the mechanism for why it has beneficial effects?
I think this is a billion or trillion dollar question, because, for example, calorie restriction increases lifespan. It was known almost close to 100 years ago. The discovery was made, and we are still trying to figure out why. We know that exercise is the best medicine because exercise improves mood, does so many different things, and we're still trying to figure out. Similarly, what I think is we're just beginning to understand how this time restricted eating improves health. But we have the luxury of knowing what else improves health. So, for example, we know, say, metformin, for example, which mimics fasting, acts on a kinase called AMP kinase. That's a fasting induced kinase. And that, when it is triggered, then it triggers one thing, that is burning fat. It triggers fat oxidation and a lot of different things. So that way, we are fortunate enough that we are kind of leveraging the wisdom of the field, the discoveries from many different people, many different scientists and leaders. And what we are finding manifold. One is, when people do animals, mostly because we do animals research, so then we can go and take out the tissues and look at the molecules. What we find is, when animals do this time restricted eating, then their pancreas gets enough rest to prime the cells to produce just enough insulin when the mice start eating. So the pancreas does not produce excessive insulin during fasting time. So the fasting insulin level actually drops in mice that do time restricted eating.
And then last, for the 10th on the list for the favorites of 2021, episode number 63, which actually I think was the first episode of 2021, which was a deep dive into insulin resistance with Professor Ben Bikman. So, Ben he's one of the foremost authorities on insulin and insulin resistance, as an academic who does research on this. And in this clip, actually, we sort of talk about the difference between the academic and the clinician. How the academic has the time and the interest and the curiosity to explore questions and to ask the questions and look for the answers. But the clinician really doesn't have that luxury nearly as much. And so it's an interesting perspective from Ben. But also the whole episode really goes into much more detail about insulin resistance. And is it really a cause to explain all these comorbidities that it's related to? And what's the strength of the evidence, and how can we put that into practical perspective? Hyperinsulinemia and insulin resistance are correlated and potentially causative of so many different diseases, which originally, sort of, at least me as a physician, the way I was trained and thought was that they were all sort of separate. Alzheimer's is very different from heart disease and high blood pressure, which is different from diabetes, which is different from cancer. But really, there can be sort of an underlying unifying mechanism that at least makes them more likely to happen. But yet, here's the disconnect between having the evidence to say that's the case and the medical community sort of accepting that. So, in your assessment, knowing you're not a physician, which probably gives you an advantage in this setting, why do you think there's a disconnect there?
Yeah. I what an excellent point. And in fact, Brett, one of my, it's an interesting thing to be the PhD biomedical scientist, claiming to have insight into clinical practice when I have actually no experience in the clinic. And my hope, but kind of as an answer to this question, in all humility, the advantage that the PhD has is that The PhD scientist gets paid to ask questions and to find answers to questions. The MD or DO physician does not get paid to be curious and to ask questions. The MD and DO gets paid to see patients. That is the mechanism of compensation. And so, I get paid to be curious, so I can just kick my feet up, look out the window, and ask, well, how does insulin resistance cause hypertension? And I can go in and find the 5 distinct mechanisms that explains this connection. But it's not fair for me to say, well, an MD, you should know this. I'd be talking to my physician friends and say, well, of course you should know this. No, they shouldn't, because that's not their job. They don't get paid to be curious. And I don't mean that in a derogatory way. The mechanism is simply you get paid to see patients. So the hospital would say, see your patients. And if the physician were to say, you know what, I'm going to take an hour off right now and just do some PubMed searches and find some answers to some biomedical questions, that's not going to get them very far. And so I think the disconnect, to answer the question, is maybe in fact it's reflected in what you said earlier, where there are knowledge gaps. I don't remember exactly what you said. 50% of what we think we know will be found to be irrelevant or outright wrong in a few years from now. And I think that I think it's happening. I think that there is a growing awareness, and this is my central thesis of the book, and even my professional goals. It is to help people understand that they're, to varying degrees, not 100% probably in any situation, to varying degrees, insulin resistance is a fundamental part of most chronic diseases. And the sooner we acknowledge its role, the sooner we can detect it as a problem and perhaps as a causal problem to whatever the disorder is we have in mind, and the better we can treat it. And that is most explicitly evidenced in type 2 diabetes, which isn't surprising because that's the disease that is most explicitly a consequence of insulin resistance. But our ongoing obsession with glucose means that over the years of the patient's life, their insulin is climbing, reflective of the insulin resistance, but it's enough to keep the glucose in check. And so because conventional medicine is only looking at the glucose in the context of metabolic health, the hyperinsulinemia is missed. And that it is only 10 or 20 years later when the body becomes so resistant to its own insulin that now the glucose is climbing, and then we detect the problem. So if we shift the paradigm away from glucose onto insulin, we first of all detect the problem sooner, because we can detect the elevated insulin much, much sooner before the glucose starts to climb.
So there you have it. There's a walkthrough of 10 of my favorite episodes from 2021. Of course, there are so many others that deserve mentioning, but I had to limit it to 10. So these are the ones that made my list. And again, I just want to say thank you for coming along with us this year and all our episodes and our 2.2 million views and downloads. It's been an honor to be your host, and to be honest, I've enjoyed this so much. I enjoy all these interviews. I learn so much, and I love connecting with my guests, and I hope that translates to something helpful and useful. So please give us your feedback. I want to hear more from you about what can make these interviews better, more helpful, more interesting, as we continue in 2022 with hopefully a whole new list of wonderful guests, great episodes. And I look forward to doing this in December of 2022 and picking my 10 episodes. And hopefully it'll be as challenging as it was this time to pick only 10 out of the multiple wonderful episodes. So I hope you have a great new year. Be safe, be healthy, and we'll see you again in 2022. Take care, everybody.